Today I'll solve some numerical problems related to density, molality, volume, normality and conversion matrix. So here is the problem statement. Assuming at NTP air contain 80% nitrogen and 20% oxygen by volume, calculate the density of air. So volume percent of nitrogen, that is 80%, volume percentage of oxygen, that is 20%. At NTP, P is 101325 kilopascal and T is 273 Kelvin. And universal gas constant R is 8.314 joule per mole Kelvin. So we know volume percent is equal to mole percent. So from here, step 1, mole fraction. So we know volume percent is equal to mole percent. So if volume percent is given, so we can easily calculate mole percent. So that mole percent will nothing but a mole fraction. So mole fraction is nothing but individual mole by total mole. So now here, as volume percent of nitrogen is given, so that is 80%, so mole fraction of nitrogen is 0.80, mole fraction of oxygen is 0.20. And molecular weight calculation. So average molecular weight, we know that average molecular weight formula is summation of xi and mi. So xi is mole fraction, mi is the molecular weight. So I is equal to 1 to n. So here that molecular weight of nitrogen is already we know that is 28 gram per mole. Molecular weight of oxygen, that is 32 gram per mole. So now m air, average molecular weight of air is, so mole fraction 0.80 and into 28 of the nitrogen, that is molecular weight, plus 0.20 into 32. So 0.20 is the oxygen mole fraction, 32 is the molecular weight. So if I do the calculation, we will get 28.8 gram per mole. So that is 0.0288 kg per mole. So this is average molecular weight of air. Now density calculation using ideal gas law. So we know the density is nothing but Pm by RT. So P is the pressure, M is the molecular weight, average molecular weight, and R is the universal gas constant, and T is the temperature. Now here, so that P is 101325 into 10 to the power 3 Pascal, and then average molecular weight, so that is you can see here, so that is kg per mole. So this is kg per mole, and universal gas constant, and this is Kelvin, and universal gas constant, we know that unit is joule per mole Kelvin. Okay, so this is joule per mole Kelvin. So joule is nothing but Newton meter. So if we do the operation, so here 10 to the power 3 will come, here also 10 to the power 3 will come. So now you will get, that is 1.285 kg per meter cube. So density of the air at NTP is approximately 1.285 kg per meter cube. Next I will talk about molality calculation. So here is the problem statement. Calculate the molality of the solution prepared by dissolving 250 gram of sodium chloride NaCl in 1.5 liter of water. So here first given data. So mass of NaCl is 250 gram. Volume of the water 1.5 liter. Now density of water, we know that 1 gram per cc or gram per centimeter cube. So now molar mass of NaCl, so that is 58.44 gram per mole. So Na 23 and Cl 35. Na is 23 and Cl is 35.44. If you take that, so that molecular weight, molar mass of the NaCl 58.44 gram per mole. Now moles of NaCl. So moles of NaCl means mass of NaCl by molar mass of NaCl. So mass of NaCl is 250 gram by molar mass 58.5 gram per mole. So that will be 4.28 mole. That is mole of NaCl. Now calculate the mass of solvent in kg. So that mass, the solvent volume is given, so that is 1.5 liter, and density we know that 1000 gram per liter. Okay, so that is density. So now V into rho, if you multiply, so liter will be cancelled out, so that is 1500 gram, so that is 1.5 kg. So now from here, so we know that molality is nothing but moles of solute by mass of solvent in kg. So moles of solute we know 4.28 mole, and mass of solvent in kg, that is 1.5 kg. So from that we will easily calculate that molality is 2.85 mole per kg. Now coming to the next problem. So volume calculation at standard condition. So here example is calculate the volume in meter cube occupied by 30 kg of CH4 at a standard condition. Okay, so now here mass of CH4 is given 30 kg, molecular weight of CH4, that is C bar O, C 12, and H is 4, so that is 16 gram per mole. So at standard condition 1 kg mole of gas is nothing but 22.414 meter cube. So you have to remember that. So based on that we can do the calculation. First, number of moles, so mass by molecular weight. So 30 kg is the mass of methane and 16 is molecular weight. So from here that 1.875 kilomole is the CH4. Now after getting that, calculate the volume occupied at the standard condition. So we know that 1 mole of gas occupied 22.414 meter cube. So 1.875 kilomole gas, how much volume will occupy? So from here we can easily calculate. So 1.85 into 22.414, so that is 42.04 meter cube. So the volume occupied by 30 kg of CH4 at standard condition is 42.04 meter cube. So next problem, I will calculate normality calculation of HCl solution. So here problem statement is convert 490 gram per liter of HCl to normality. You have to convert normality N. So for that, given data, concentration of HCl, that is given 490 gram per liter. Molar mass of HCl we know that 36.46 gram per mole. And valence of HCl, so that we have to remember, we all know that is 1. So moles of HCl, so mass of HCl by molar mass of HCl. So mass 490 gram and molar mass of HCl is 36.46 gram per mole. So from here we can easily calculate moles of HCl. So 13.44 mole per liter. So after getting that moles of HCl, we can calculate molality. So molality is nothing but molarity by valence. So molarity is nothing but mole per liter. So here, so we choose that concentration, that is gram per liter. So from here we convert the mole, so that is 13.44 mole per liter, and valence is 1. So normality will be 13.44 N. N is normality. So normality of the HCl solution is 13.44 N. N is normality. Next, I will talk about conversion of normality to gram per liter. So convert 4 N normality solution of NaOH to gram per liter. So normality of NaOH solution 4N, that is given. Molar mass of NaOH we know, that is 40. So Na is the 23, oxygen 16, and hydrogen 1. So from that we can easily calculate molar mass of NaOH, that is 40 gram per mole. Valence of that NaOH, that is 1. So calculation of the equivalent weight of the NaOH. So equivalent weight is molar mass by valence. So that is 40 gram per mole, so by 1. So that is 40 gram per gram by equivalent, means we are doing that equivalent weight. So 40 gram equivalent. Okay. So after getting that 40 gram equivalent, so we can calculate the gram per liter. So gram per liter is a normality into equivalent weight. So gram per liter will be 4 normality into 4 gram per equivalent or gram equivalent. So that is 160 gram per liter. Next question, before that we need to get some relation. So the ratio of ideal gas flow in two state can be used to eliminate R. So that is P1 V1 by P2 V2 is equal to N1 T1 by N2 T2. So grouping pressure, volume and temperature give dimensionless ratio, that is P1 V1 by P2 V2 is equal to N1 T1 by N2 T2. So both sides are dimensionless ratios. Now here is one problem. So calculate the volume occupied by 120 pound of methane at pressure 40 ft, 40 feet of water and 25 degrees centigrade. So pressure is 40 feet of water and that volume is 120 pound. Now molecular weight of methane we know that is 16 pound by mole. So number of moles, so 120 is the mass of the methane by molecular weight, so 7.5 pound mole. Now standard state calculation are, so P1 V1 is equal to N1 RT. So standard state we must know the pressure is equal to 33.9 feet of water, so that is nothing but 1 atm. Okay, and volume is 359 feet cube and N1 is 1 pound mole and T2 is 273. Now if I plug all this value we can easily calculate R. R is in foot of water, feet cube, mole, pound mole Kelvin, so that is 44.59. So taking that we can easily calculate the volume. So now P is given, so 40 feet of water, T is 25 degree centigrade. So from here we can convert, that is 298 Kelvin. N is 7.5 pound mole. Now from here V is equal to nRT by P. So N is 7.5 pound mole, R is 44.59 we have calculated, and then temperature is 298 Kelvin and P is 40 feet of water. So if we do the calculation, so we'll get that volume of that volume occupied by 120 pound of CH4 at pressure 40 feet water and 25 degree will be 2477.85 feet cube. Next is conversion. Now we got in the FPS unit. Now if I convert in the SI unit, so whether we will get same result or not. So we know that 1 feet cube is nothing but 0.0283168 meter cube, and 1 feet of water is nothing but 2989.0669 Pascal. Okay, so we know that 39.9 feet of water is nothing but 10101.325 that Pascal. So from here we can also calculate the 1 feet of water. Now convert volume into meter cube. So that volume we got the earlier calculation, that is 2477.85 feet cube. So if we convert in meter cube, so conversion factor is 0.0283168. So after doing the calculation we will get 70.12 meter cube. And pressure conversion, so 40 feet of water. Okay, now here 1 Pascal or that 2989.06 Pascal is equal to 1 liter of water, means 1 feet of water is nothing but 2989.0669 Pascal. So I told you that this conversion you can take. So 1 feet of water will be 101.325.39.9. So now pressure will be 11.99562.68 Pascal. So now we know volume, we know Pascal. Okay, so N is given, so that is 3.402 kilomole. So 1 pound mole is equal to how much kilomole? So that is 0.45359.237 kilomole. So now after that we know that N, we know R, we know temperature, we know pressure, so we'll get 17.56. That we convert here, so same, we'll get same result. If we still, there is slight difference, but that result is nearly same. The volume occupied by 120 pound of CH4 at pressure 40 feet of water and 25 degrees centigrade is 17.56 meter. That's it for today's class. I'll talk more about in the next class.